I hope I can actually keep you guys awake. I know the after lunch slot is always a tough one. A couple things before I actually get started. I have fsharp.org stickers here, thanks to Evelina. So if you guys would like one, you should definitely first check out fsharp.org. The foundation is a really wonderful resource on all things F# and things you need to get started, more information on all things F#. It's a wonderful, wonderful resource, fsharp.org. We also finally got the Jet sunglasses in addition to the Jet headphones, and I know they're out circulating somewhere, so if you guys want more swag from Jet, that would be really, you can have some more. I was handed one pair. I know they're out somewhere else, so I don't have more for you guys, but they're here at the conference. F# also has a mentorship program run by fsharp.org. If you go to fsharp.org/mentorship, I believe, check that out as well. I don't recall the exact details, but it's a few hours of a mentor's time and a few hours of your time, and you can just basically ask questions and help solve problems and figure out, if you're just getting started in F# or if you're having a particularly difficult problem, you can work with someone and sort of sort that out. It's a really wonderful thing. A few people have started to sign up, and I'd love to see it go further. So, my talk now. Building reactive services using functional programming. It's the talk in general is basically how to make F# perform reactively. So I work for Jet.com in the States. Very quickly, we're an e-commerce company. We're taking on Amazon. We are basically exclusively an F# shop, which is a very weird and very awesome, I think, thing. Mostly, we are hiring. We have an office in Dublin, if that's, that's a little more convenient than moving to New York City for you folks. But definitely see me if you're interested in full-time F# work. This is, in addition to F#, this is some of the other technologies we use. We're heavy users of Azure, as we are taking on Amazon. We are not heavy users of AWS. So, we use from Azure, we have the VMs, we have SQL Azure, we use the Service Bus and Active Directory. From F#, some of the libraries we use, Packet and Fake, FSblog, Unquote. We have Node and Angular on our front end, R and Python and Sass on the for our data science. And then down here in green is sort of everything else that we use. Well, not everything, a random assortment of other things. SQL Event Store, microservices, Kafka, Redis, Storm. We're we use a lot of different things. Xamarin used to be in here, should be in the bottom section as well. So it's a pretty fun place to work. But on to reactive services. The Reactive manifesto, which was, updated somewhat recently in September of 2014, the new one has 4 main tenets. Elastic, responsive, message-driven, and resilient. And these are what today's modern applications should be. And I'll go into, I'll take each section and sort of talk about how to make F#, be each one of these things. So responsive first. Let's look at events. Events can, almost every program actually has to handle events, whether it's clicks in a user interface, listening to sockets in a server. It's basically just a reaction to a change in state. So events in F# implement iObservable. They are composable. They are first class, and they are immutable. So, by immutable, obviously, I mean they don't change out from underneath us. And obviously, concurrency in any form is very difficult without immutability. They implement iObservable, so events are of type iEvent, and they inherit from this. Something the reactive extensions also do. And by first class, just like functions in a functional programming language, we can pass them around. They can be an input into a function. We can return them from a function. We can filter and transform them. We can actually, by composable, we can, in addition to filtering and transforming, we can compose all of the operations. So, this is perfect. We can do stuff like this. So in F#, the pipe is very, very common. It's, I would say almost a mainstay of F# programming. It's important enough that when the F# community redesigned our logo, we based it around the pipe symbol. But here, this is a short little, very real-world demo program that if you click quickly, it'll add 1 to a counter, and if you click very slowly, it will add 4. So, but basically, we take an event, we map it, grabbing the current date time, we scan through to see, what the last timestamp was, and then add 4 or 1, and map and grab the first one, add that, print out what the actual number of clicks are, accumulating that total, and then set a label, set the text for a label to that. But it's very composable and very easy and quick and linear to see what's happening there. So these functions, map and scan and everything, are actually called combinators. We have add and choose and filter and map and all of these other things. We can also create our own. So, down here, event.using is the one that we're creating, and the code on the top is how we would actually create one. But because we can create our own, in this case, just setting a new color, creating a new paintbrush color from that color. But because we can create our own, we can add, we can turn a series of events into an event stream, which handles very much like an iEnumerable, and our code looks like we're programming against sequences. It's very convenient, very easy, very lovely, I would say. My phone with me? Perfect. So, message-driven, to move right on. Before we move on to message-driven properly, I wanted to talk about async workflows, which are basically an application of F#'s computation expression syntax. And if you want more information on async in general, there is a really great blog post by Tomas Petracek, which I saw somewhere back around, on the differences in C# and F# in async. And you guys should definitely Google that and find that blog post. But before we go on to even digging into async, first of all, I wanted to make sure that we were clear on the difference between async and concurrent and parallel. So asynchronous is basically just specifically non-blocking. So usually in reference to I/O operations, not necessarily even parallel, just means non-blocking. Concurrent, multiple operations actually happening at the same time, but not necessarily in parallel. And in parallel means, multiple operations happening at exactly the same time. So concurrent means a little bit of one thing will happen, a little bit of one other thing will happen. And it basically goes back and forth very quickly, so it seems like they're happening at the same time. But to move back to, so I know a lot of audiences, and me especially, a few years ago, were very confused about those things. So I like to always throw that one in there. So computation expressions. So I had said that async workflows are a implementation of the computation expression syntax. Computation expressions are, a lot of people think of them as monads, is the first thing I wanted to talk about. It's a single syntactic mechanism which gives a nice syntax for multiple abstract computation types. So yes, we can think of them as burritos, and that is really lovely. And they can be monads and burritos. They can also be a lot of other things. It doesn't have to be just a monad. So you can be monoids, additive monads, basically an entire feast of delicious food. It's not just burritos. Bad jokes, I'm sorry. This is supposed to keep you guys awake after lunch. But the main point here is that it is not just monads. There are lots of different things that can go into computation expressions. So async workflows are a computation expression. It's very, very, very easy to convert classic code into an async workflow. And it reads very similar to the classic synchronous code, which makes it obviously very easy to understand and reason about. So here is some classic code. We have a web client, we're downloading some data, and outputting the length of the data that we just grabbed. Here it is in async. We have, the new web client here. We're grabbing the same data here, and we're printing out the same thing at the bottom. The main differences are that we've wrapped it in this statement that has async and curly brackets. We have a let bang instead of a let without the exclamation mark. And we have an async download string instead of the web client.download data. Those are really the differences. That's how you would convert this over to using an async computation expression. Let bang will start the computation immediately, whereas let here within the async expression creates an async object for use later. So you can evaluate that later once you need to. And then the printout here that's what that would look like. So here's another example just within a recursive loop. You have a let rec is how you declare something to be recursive. And again, you have an async, and you're waiting an event, printing the clicks. You also have the do and the return syntax. You also have a back pipe, which is the same as a forward pipe, but the things are reversed. So it's just one more example of another way to use this as a way to get into the actor model. Now, I know a lot of you folks here actually work with Erlang, and most of you here are probably familiar with it, so you will know fairly well what the basic tenets of the actor model. But it's a model of concurrent computation using actors. The four main pieces, I would say, dynamic creation of actors, inclusion of actor addresses in the message, interaction only through direct asynchronous message passing. So that obviously the message passing is the huge part of this, and no restriction on message arrival order. So putting together all of these pieces, the message-driven part of Reactive is actually done using the actor model. And what is an actor? An independent computational entity which contains a queue and receives and processes messages. Carl Hewitt, one of the folks who discovered the actor model, one of the things he said was that one actor is no actor, and they come in systems. So I know one of the examples I'll often use is Erlang was originally developed for use in phone systems, and if you have only one telephone, there's not really anything you can do with it. So you can sit there and hang it up again, I guess, and listen to it, and you can speak into it, and you just can't really do anything else with that. Who are you going to call? You can't have just one implementation of one actor. So this is one of my favorite ideas, is looking at a subway. This one in particular is the Tokyo subway map. But you can think of each station sort of as an actor. There are trains as messages that come in, and each station sort of processes the trains. Some folks will get off and switch to another train and continue on. Some folks will get off and leave, maybe error out. Some folks will just continue on that train to a new station. But some processing happens at each station for each message train that comes in. But specifically here, there is a path from any station to any other station. It could be complicated. It might involve 8 transfers and be really inconvenient. But there is actually a path. And each one of these is actually named. And I think in any decent subway system, they are all named different things. So basic syntax for agents. Here I have a huge loop. I'm creating actually 100,000 different agents and posting to them quite quickly. A point I often need to make to C# crowds is that they're not threads. These are very different than threads, but I imagine that most of you folks will know that. I can obviously create thousands on my laptop. But you see the async workflow in the center of that. Basically, the mailbox processor is an async workflow with a loop inside of it. You can use a while true loop. You can also use a let rec loop. I have examples of both, I promise. But you contact the agent by just saying, an agent.post will post a message to that specific agent. And this will print out, for every 10,000th agent, it will print out a ping here. So just to show you guys what the very basic syntax is for working with agents. So they are also called mailbox processors in F#. Folks will still refer to them as agents. Occasionally, because of Erlang, folks will also refer to them as actors. They all mean basically the same thing in the F# instance, mailbox processors. To be able to get replies from an agent, you have the same mailbox processor. Here we have a recursive loop with an async workflow inside, where, so here, we have the let bang message inbox receive. That's where we actually take the message and then we process it. Here, instead, we have the mailbox processor has a tuple type, both a string and an async reply channel. So the async reply channel is how we actually are able to process replies back out of that agent. And so when we're receiving our messages, we can decompose them right away into a message and a reply channel, and then use the reply channel to just reply back. And then if we specifically are intending to receive a reply from that agent, we need to use post and async reply instead of just a post. So the main pieces here are including the async reply channel, in the mailbox processor type, receiving it as part of the message, using the actual reply channel to reply, and then calling post and async reply to actually, ensure that we get that message back. So this is from a short demo app that basically just it's a little command line thing, will repeat back what's printed into it. It just sends out to an actor, and that actor will, just print, like it says, received a message, and what the message was. There's also a way to scan a specific queue. So this is another small demo app. It can spin up a few different jobs and then cancel them if needed. So the in-progress agent basically just keeps a list of everything that is currently in progress, and the completed agent prints out that a job has finished. So these are two of the agents that it uses. This is how we actually do the scanning. There's a cancel job. So basically, if you say, I have jobs, 1 to 15 running, I'd like to cancel number 7. You scan the in-progress agent .scan, and using the job ID result in the source, and do a cancel if needed. And if that job hasn't already finished, and you do actually find it, then you return an action to further cancel that. So one major difference from Erlang, and I always feel a little weird giving this presentation in front of anyone who actually knows much about Erlang, but F# agents don't work across process boundaries. So that, I feel like, is sort of a major failing. In many cases, that ends up being perfectly fine. There isn't much need for that if it is all within one project, one set of code, then you are fine. But I know this is a fairly big deal to a lot of folks. So there is a library called Cricket, which can handle remoting. It used to be called F# Actor. I know that was changed maybe a year ago, but you can still Google for both. So the way Cricket actually works, slightly different syntax. Basically, the way you declare the actor is with using actor inside of curly brackets. Declare the name. So, every actor needs to have a name, where you're going, what the actual address of the actor is. And then within the body, you again still have a recursive loop and a message handler that basically defines how you should be handling that message. So You receive the message, and in this case, depending on what the message type is, and here it's just a discriminated union of hello, hello world, or a name. It's, again, very real world. It's this code that I use in production every day. So either print hello or hello world, or hello name. And then the way to, instead of a MailboxProcessor.start, you can pipe this into actor.spawn. So the syntax is fairly similar. It has all of the main basic pieces of a mailbox processor. And then, again, this is how you would do an agent.post. Send to the greeter actor, something, and here it would print hello from F#actor. Remoting, this is how you would actually handle remoting. You need to set up and configure it properly to handle this, but it is possible to actually handle remoting. When you do have remoting set up, there's a great little example that he has, which basically has two actors playing a game of ping pong, and it'll just go back and forth and back and forth. But once you have remoting set up, and once you've declared that you need to be using remoting, the internal semantic, the actors that you use are exactly the same. So this one still had, actor, curly braces, name, ping, and a body with a recursive loop and a message handler inside, which tells you how to handle that actual message. So the internals here are exactly the same. So resilient, moving on to the third piece. Basically we need to be able to handle errors. There are three different ways that are good to handle errors. Using async.run synchronously to report back to the controlling thread. Using async start with continuations, so there's three different options, one of which is an exception continuation. And then using the supervisor pattern, that you have to sort of set that up yourself, but using that, you can also handle exceptions that way. So using async catch, here we have, moving back to mailbox processors, we have an async start, and a result comes back, and you can do an async catch and then an async run synchronously. We just throw that async catch right in the middle there, and it will catch if there's an error and print that out. This is if I'm reading and trying to read from a file very quickly. If it's too big, then that it might still be in process, and so throw the async catch in there. But it really is just adding that extra pipe between an async run synchronously and an async catch, and the actual code that you're running. So it's very good, very easy to use for basic async workflows. Here, if we have an agent that's trying to reply, and we have our agent post an async reply, and then from there we have an async start with continuations, and the first one is the successful continuation if everything works out fine. The middle one is exception. The final one is cancellation. So here again, just add in the correct path, the correct way to handle the error, and you have a more resilient system because it's able to handle these errors. And for another example of starting with continuations, here, this is the agent that will, or the demo that will actually cancel the jobs. So here, we're posting to the in-progress agent, and then we have an async start with continuations that, posts to the complete agent when it's finished. And in this case, it doesn't do anything with exceptions because it's, this very real-world small bit of code. And then here we have the cancel exception, which will cancel this job. But it is a very common pattern to use this start with continuations to be able to handle these errors. And supervisors, so this was actually a fun app, I wrote a very quick sort of proof of concept. When I first learned about the actor model, and I had been learning F# a little bit. I thought it was just the neatest thing, ever. And I decided to do a proof of concept to be able to handle the email that was coming in at our current company. That company was sort of like Jet. We had to send a lot of, thank you for signing up. Here's some more information. Here's, your weekly email on stuff you might want to purchase. So all of those sorts of emails. And I had, a flow of agents to be able to handle something like this. Certain templates, certain data that needed to be input, and then certain different, I needed a way to model errors. And I used a supervisor error agent that basically, I could post up to the error agent and say, hey, this is the error that I received. If it's something you know about, try to fix it. Otherwise, error out and write into the log. And so, since, again, this was a proof of concept, I had a massive set of data and, several different templates, and it would, I'd start by posting to the first agent, which would sort out what type of email needed to be sent, go off to a couple different templating agents. When those were finished, they would go individually to the mailing agents. And the errors that I needed to make sure that there were actual errors so I could make sure that my erroring agent was working. So I chose, in cases when an email had, I think, the letters A and N together, it would fail. And the cases when it had E and N together, it would fail. It would fail unrecoverably. So if it had A and N together, then it would remove either the A or the N and retry. But in some cases, again, you will know how to solve an error. Maybe it was just a network timeout and you just try again. Maybe you wait 10 minutes and try again. There are obviously cases where you have an idea of how to solve those. So the erroring agent can do those sorts of things for you. But here, I have my error agent at the top, which takes in a system exception and basically just prints that out in this case. Here, agent at the bottom. In this case, so I lied. It's the next example that actually is the app I did with emails. This one just takes prints, message to agent with a number, and in the case when it has 99 in it, whether it's 99 or 990 or 9900, it will fail and post up to the error agent and print something out. So this was my email example. So yeah, it'll replace AN together with just A and then retry. But with down here, you cannot send retrying failure, and the else if if the message contains templating, there was some error in the templating, then just fail completely because we have no idea what's going on. But again, obviously there are ways to keep your solution, your code resilient because of the ways of handling these. Perfect. So Elastic, the last one. You should be able to scale agents on demand. And obviously Azure can do lots of these sorts of things for you. But in this case, there's also, jumping back to the async code from the very first example, if we're trying to grab a certain amount of information from a website, you might have a list of 3. You use a processing agent to actually process that information. And coming down here, you take that URL list and you iterate and create a new instance of the processing agent for every item in that list, automatically going out and getting that information. So if there were 30 of them, it would spin up 30 agents in that case. And it was very elastic, very easy to keep that information going, and scaled and going out and very quickly. So I went a little fast. Are there any questions? So I imagine there will be. There's additional resources. But obviously, like I mentioned, definitely check out fsharp.org. The Twitter hashtag fsharp is usually really well maintained and paid attention to. A lot of folks will answer questions if you guys have questions. There is a channel on the functional programming Slack for fsharp. I think there's an intro one and a general fsharp one. Might be a couple others too. I would highly recommend both fsharp for Fun and Profit and fsharp Weekly. The fsharp for Fun and Profit is Scott Vlashin's website. He has a tremendous amount of very accessible information, just very in-depth, very useful, good information on fsharp. fsharp Weekly, Sergey sends out a weekly email on what has happened lately in fsharp. There have been pull requests, if there are new videos, there's new blog posts, just a complete rundown of everything that has happened in the fsharp community in that week. For mailbox processors and async, in addition to Cricket that I haven't mentioned up here, there's the Orleans project and akka.net, both of which I don't know quite as much about, but are very good and very well respected. And I would say, I assume basically comparable. So are there questions? Sure.
And do you use Cricket inside, your company? And what was the reason for taking it over akka.net or Orleans, for example?
So we don't actually. I was interested in Cricket before I actually joined and thought it was just a really cool project. It was before either akka.net or Orleans were very big, and so this was just the first actor library I had heard of. Was my main reason for including it here, really. I've worked in a couple different teams, and at JET, the teams are sort of autonomous, and you can choose your technology. As far as I know, none of the teams are using Cricket. But don't quote me on that, because in 3 days, that'll change. But yeah, my main reason for including it in the talk was that I knew about it much better before the other two were larger products. One more thing before we go into this talk. fsharp conference is happening March 4th. It's a completely online conference, and I will be speaking. I know several of the folks who are speaking here will also be speaking. It'll be a great, great conference, and I would highly recommend everybody watch. And I believe all the talks will be recorded as well, and so you can jump on and watch those later. Yes.
Yes, this is a fast comment to the other question that why would you use Cricket? I think that it's very simple, in a sense that can you have, for example, in akka.net strongly typed messages, or are they just objects or all? Okay, and then yeah, but like earlier versions you couldn't, but then also this kind of that you can use Cricket so that you, for example, send the messages to Azure Service Queue or something, and it's quite well enough usually. So it's very simple and can be enough.
That's a good point. Do the other two do remoting? Because that was, okay, never mind. That was my main, another one of the original. I was like, oh, you can do remoting. This will solve my friend who does Erlang, who always harasses me about that.
So, thank you for this great talk. I would ask you about back pressure problem. So, what about that? What's the story?
I have no idea.
Because akka.net doesn't provide you anything. So, another question. So, when you send a message right to the actor, can you wait on the response? Because when I use, for example, CQRS, right? So I send command, for example, and I want to really get the answer. I really need kind of fact that message was delivered to some actor. So with Akka.NET, it's also not possible. I mean, it's at least not easy. Yeah, it's possible, but it's bad approach in Akka.
Well, actually, you.
I have also a third question for you. So.
I would imagine so, but I don't actually know. That's not something I have needed.
Yeah, so I'm wondering how you distribute, how you specify where your actor will exist on which node. Because in Akka it's also an issue because you need to specify exactly. You can use cluster, but it's also not easy. So with Orleans it's much easier. So and yeah. I don't want to.
I don't know. I'm sorry.
Okay. Thank you. Thank you.
Well, quick comment for the earlier comment also that's actually one difference between agent model and actor model that who controls the workflow and who is the control of the work. And also this is like asynchronous, of course. So basically, you don't get the message back immediately, but you can use this, for example, Cricket or actually F# mailbox processors. There is this async reply, and there is also the reply.
Yeah, with mailbox processors, it's a little easier to wait on that. In Cricket, I am not certain. Anything else? Thank you guys very much. This was really fun.